Wieler.
Hello, good morning or good afternoon or good evening, wherever you are. So, welcome to my presentation about technical due diligence. And how I can improve your project value. First of all, I would like to raise your mindset to what technical due diligence means. Everybody probably has tried to buy or thought to buy about a car. So when you buy a new car, you never know what you buy. You think, and what is always by the seller told you, it's a nice new car, shiny, and hopefully fully functional. But unfortunately, this dream appears into a nightmare. So the question now is, how can we make the right decision? It means, how can we prevent buying a broken, shitty car next time? Short about my person. I'm in the wind industry since 2005. I've worked for 2 turbine suppliers and for several companies developing and operating wind farms. And since 2014, I'm with TÜV SÜD as a technical due diligence expert. In parallel, I'm also giving lessons at the Austrian University. So what we want to speak about today. First of all, I want to show you the definition of due diligence, how we understand it. Then, how we apply this in a wind farm. What is the interest when we do our wind farm TDD? How the analysis in itself is running. The findings we can have, how we deal with the findings, and how we gain the added value. But before we start with the full presentation, I have a few questions to you. My colleague Ms. Böhler has now placed into a chat a link where you can attend the question round 1. So, my first question to you is, what do you think is due diligence? Is it an investigation, an act of care, or both? And connect directly to this when it's applied. Before entering a business, before making a decision, or at any other time. So, the screen will be shared in a few seconds. Okay, we have a few answers. Let's wait a little bit more. Okay, good. Oh, quite interesting. Everybody's thinking it's both. It's not only one. This is very nice. Yeah, and quite good. A lot of you think it's necessary to do before make a decision. Nobody at other time. Okay, that meets exactly my expectation. So, so when we what is due diligence? When we come to the pure definition, according to Wiki, we see that this written there. This is an investigation, an act of care. It is something we should do before we entering an agreement, contract, or do it as an act of certain care. This is quite technically. What does it mean in practice? Actually, due diligence is an act we do in every day in every decision, hopefully. So in terms of a wind farm, first of all, let me explain how the structure of such a project is. We have in time-wise, in the beginning, the planning, the feasibility and design status, or if we have already an old wind farm, a repowering. In terms of the next step, time-wise, we start the manufacturing and construction. And then we're reaching the longest period, which is the operational period, where you have to do your maintenance and optimization of your wind farm. And then we have a quite short period in the end of the wind farm, ending the life cycle. It's a decommissioning or repowering. So among all those different steps and phases of a project, we have several subtopics. The first one is the type and prototype certification and testing. This was presented in a previous session. We have, of course, also in the beginning, the feasibility studies. We have, up to a certain point, a project certification, which is quite important for offshore projects. In parallel, we're starting to introduce owners engineering and landers engineering. We have a risk survey, which is to be run over the full project period. And we have also, starting from the beginning until the end, the review of the permits and all the required inspections. When we're looking time-wise in the second phase, we have to look into quality and control, especially when it comes to production or the erection of the wind farm. Coming to the longest phase, we of course have always a monitoring, and in some cases, unfortunately, a damage analysis. And coming to the end, there's theoretically not really an end. You can also think about a lifetime extension if you want, for what reason ever, your project longer. So, and due diligence, so meaning to think above everything you do. It's above everything in every step you have to apply. So, in a wind farm, we have in general a team sitting and thinking what we start first. This is the point in time where we have the highest degree of freedom. Most developers like to have a greenfield project because they still have a lot of degrees of freedom, except the site maybe, but this is still everything open and can be controlled. This next phase, degrees of freedom, and where you can buy a project, is in construction. That means every permit is achieved, every contract is signed, and the project can be started to build, because here's still some risk during the building. But you also can buy a turnkey project. Turnkey means that the turbines are completely erected, connected, and you just turn the key like in your car and start earning the money, free of all risk. And then the next type of project is a project which is in operation. This is a project which is usually a few years old, maybe has already passed the warranty period. Everything is settled. you don't want to care about anything, you just want to have a green asset. And then we have the option of a repowering project. It means you buy an old wind farm, which is maybe 15, 20 years old, and you want to replace the old turbines with something new. I have another question round for you. Ms. Bühler has shared already the link in the chat. And so my next question is, what are core topics for due diligence for you? Here are more than one answer possible. Then, also for me interesting, when do you apply a feasibility study? In a few seconds, we will see the screen. Okay. Well, this is quite interesting. We did this session before, and in the previous session, we had on this question a lot of different answers, and here everybody agree you should apply all of them, except one person is only doing site assessment. Okay, now we have a little bit more variety. Give it a few more seconds, okay. Okay, in the feasibility study, you apply most of you when you enter a greenfield project. This is quite nice. Yeah, I mean, there is, regarding the second question, there is no right or wrong, but it's quite interesting to see that most of you really start the greenfield project with a feasibility study. Oh. What does it mean? When you start with project we have discussed before, whatever, you have a planning and preparation phase. Of course, in this phase, you already spend some money, but this is a phase where you at any time can stop the whole process. But if you pass the tipping point, so to say, make the decision, we do it and execute it. We remove this green piece of wood and we start to spend the money. This is, I recommend always to have in mind when you do your due diligence. From my perspective and from my view, the core topics you need to have in order to do a due diligence is a feasibility study, a site assessment, permit situation cleared, and a grid connection. On this basis, you could start a project. Let's take us a deeper look into this. On an example. So, over time of our development, we start always with a wind measurement or with a wind data analysis in order to gain the information about the wind yield we can earn on our site. The second step should be a feasibility study or assessment. When this comes positive out, you should try to get your land lease agreement, permitting, construction and planning. And if you have this achieved, you can start with your tender and contract management, look and evaluate for suppliers and their qualifications, and do the first or preliminary design review on your project. In practice, the work of a due diligence is like this. You have a permit, and this permit is a condition. The question is, like this condition given here, an automatic fire extinction, is it included in our turbine supply agreement, TSA? If not, we have to add it to the contract. And what will happen if we add something additional to any contract? The price will increase. So that means it will have an impact on our capex, the money we need to spend to buy our asset. And this affects, of course, our project IRR, our sales price, and we have to apply it into the risk mitigation. And when we look into risk, this requirement here is not only in the TSA to be covered, it's also to be covered in the O&M agreement. This unfortunately probably means also additional costs we have to take into account, which has an impact on our operational expenditure. The money we spend in order to keep our asset running. And of course, this goes as a part into our project IRR. Theoretically, we could extend this row for a lot of other topics. But in principle, the analytic process should run. I have an information, and how does it affect all my related project parts. I'm doing a feasibility assessment. Of course, we need an production probability analysis, information about loss and uncertainty. Loss and uncertainty is also important, because when we only see our wind direction and our wind production, this assumes that our turbine is permanently operating, which is not the case. The turbine has to be stopped for maintenance, for defects and other effects. And we have to add an uncertainty to the whole process, because this wind is measured only for 1 year and we have variance in it. Therefore, our production has also certain variance or uncertainty. And in the feasibility assessment, we should have to add an assumption about our turbine. We have to build up a basic structure on our project. Think on our park infrastructure. With this information, we can start build up a financial model where we add our capex and opex. We can start to calculate the estimated generation cost for the electricity. This brings us to the project IRR. And having such a model with all those information included, we can start a first sensitivity analysis, helping us to improve our project. Coming to one of the core topics in a due diligence. This is the question always, what is the right site turbine for my site? So, and in most of the cases, the AEP is driving the selection of our turbine. Because with a good IEP, we get the funding. In most cases, bankable yield assessment is necessary. And what we do in TDD is we give the bank a recommendation what they shall assume in their models. The AP comes out of the wind analysis report, which is the report where the site assessment based on the wind data will be done and the energy yield will be calculated. When reviewing such a report, in order to give our recommendation, we have to look into the source of the data. And then the question to the bank is, are those data reliable? If this is the case, we can get our bankable recommendation, and this means the money for the funding of our project. If we have doubts, we can think over, can we get additional data? If so, do they helping us to get a value we still can achieve our money in order to build the project? But if both is not helping, we have to deal with an uncertainty. Is the uncertainty still acceptable? We still have a chance to get the funding for the project. But if the uncertainty is not okay, we have to go back and to make a new wind study and to rerun the whole process. Now, as we have found, based on our criteria, the right turbine, the first, so to say, cogwheel will be starting. Out of our technology review, we start to move the wheel on our turbine supply agreement and starting to turn the wheel on our building contracts for the site. Especially for onshore projects, the turbine supply agreement is the most important agreement because it easily can be spent up to 80% in a project. For offshore, the effect is quite smaller. There it's only 45%. But still, it is the biggest contract. I have another question round. Again, more than one answer is possible. And for me, it would be interesting to know how you review your contracts. Additionally, I would also like to know, when do you involve technical advisor into your projects? Here, only one answer is possible. In a few seconds, Madeleine will share the screen. And we will see your answers. Okay. Oh, this is quite nice to see. The majority is working here always with a larger team, which is highly recommended, taking into account the complexity of projects. One is only with a legal advisor, so it seems to me either you have a very strong technical team or confidence that you can solve the issues by yourself. Okay. Can we see the second answers? Okay. That is what we expect, what we see most, that most of you, come and ask before buying, yeah. So, seeing the answers before, I expected somebody who is only legal advisors is not involving any technical advisor at all. So I would miss him here out. Okay. Let's go and have a look in the preliminary design review. Again, this is only an example because there are plenty of various we have to take into account. But what I assume is in most projects, a question you have to review is your VTG's usability. Means it's not only about the AP, it's also about the expected lifetime, operational time you want to achieve. Coming across with this, you also should make sure that you can bring your turbine to the site. sounds like a standard topic, but it very often comes to problems here when bringing a turbine to a site. Also important for you, as your turbine shall remain on its site 20, 25 years or 30 years, the soil. You want to make sure that your turbine is not vanishing somewhere in a hole. The planning of the civil infrastructure should be also carefully reviewed, as you want to operate your wind farm for a long period. The same applies for the electrical infrastructure. And what is important and may change over time is the grid code compliance. Meaning having a contract connecting a wind farm doesn't mean that you're allowed all the time to feed in your electricity. Sometimes you have to do investments during the operational time to ensure this, to be compliant with the grid requirements. Once you have settled all those topics, you can start to build up a schedule and look into the interfaces, because there are different companies, different suppliers working here together, and they need to be linked. And of course, in a preliminary design review, you need a risk register in order to cover all possible problems you may identify and to address them. So let us discuss how important the review of the construction schedule is. The construction schedule is driven by two topics. One is cost and the other is time. In the DD, it is always plan to assess if the planning is realistic. If we can make here a positive feedback, we most likely will not run into cost or time problems. If we see a problem and need adjustment, it could end up into minor changes, which still not affecting really our time or cost planning, but they could be also a little bit bigger, and then we are not longer green, but still in acceptable range. The situation looks not so good if we find major changes. If we are lucky, they're not affecting so much our cost and time, but they also could, if you're not so lucky, then dangerously affecting or overcritical. An example could be that identified a bridge has to be built, which is a costly thing and usually a timely thing, which could kill our projects. In DDD, we have the advantage, we can stop the whole process here. So we have spent only a few amount of the money for the project, and we can use the rest in order to do another project or to readjust the whole process. But when the DD is finished and we are in the execution, this is what I've meant before, when we have passed our tipping point, there is no more stop. And we have our bridge and the project has to continue. The contract management. This is also an important topic within due diligence process. The previous topics, they were more about planning. Now we're coming to the real hot topics in the DD process. So the first contract you usually have is the wind measurement equipment supply agreement, which is a quite small contract, but it's a contract, and here you already can have troubles or save time and money if you do it right. Coming to the project execution itself, we have to think over the turbine supply agreement. As I mentioned before, this is the biggest contract and has the biggest impact to the whole project costs. Directly connected to this is our O&M agreement, which is also a big portion. Usually those two contracts are negotiated and looked together. In parallel, there's the APC agreement, which has a lot of interaction. You remember the picture I've showed about the wheels, the cogwheels acting in each other. This should be properly interlinked in the review and in praxis. Separate from this, there's a technical management agreement. This technical management agreement we need in order to have a manager to ensure the operational phase of our wind farm. This has a big interlink to our O&M agreement. The grid connection agreement, of course, is also quite important and should be closed before you start any construction to make sure that the capacity will be taken. And maybe not the biggest contract, but a very important contract, especially for banks, are your insurance agreements. They shall cover your risks, periods of downtime, which are not covered by O&M agreements or for force majeure events. Now we have seen all those huge amount of contracts. TÜV SÜD has developed here a special evaluation concept. We divide the review in two topics. One is the findings and the other is the action resulting out of the findings. So how do we do this? First of all, we have a list here which we hand over to our clients where we try to list all the open items, means points which are not covered, where we are not sure if they are critical or not, but this is something you need to review and follow up. Of course, a risk evaluation of all those contracts, and even importance is a cross-reference. The cross-reference means not how the contracts to each other are referenced. Cross-reference means how the contracts are referenced, maybe to a legal due diligence or financial due diligence, to your financial model or to your operational model, cost model, and to the insurance. With all those information, we try to build up a risk plan, an action plan in order to mitigate our risk. Well, the idea is then, with this action plan, you can deal with all the raised topics and know how to do with this, or at least follow up with them. But of course, there are topics which cannot be covered in a risk mitigation plan. They need to be monitored. Yeah. For example, during a construction period, you can assume that the weather goes bad. For example, it starts to snow, or the wind is too high that you can erect your turbines. But this is something you don't know, and then you have to monitor it. And based on the outcome, you have to make up your decision what to do. But it is a topic you should be aware of and prepare. So from our point of view, in the DDD, the value is satisfaction, because before you buy a contract, you understand the project. You hopefully have identified all the risks and can reduce them. And good DDD brings arguments for the negotiation, especially when you buy a project. Once the contract is signed, you can improve your project based on your action plan with less costs. your decision are well founded, so you can defend them in front of the bank or whoever who is questioning them. And you're in control of the developments. For the operational phase, does it mean that you are empowered to act? That means you're not reacting, you acting, you are ahead of the problem. You know how to enforce your warranties. And you have a chance to follow up with possible risks or items identified in the process before, which gives us the chance to act. Oh. Well, thank you for your attention at this time. I'm at the end of my presentation. I just want to shortly summarize here what we have spoken about. We've spoken what TDD means to the wind business. We have spoken what types of projects we usually have when we speak in the TDD business of wind, how TDD should help to find the right project, to save you time and cost in a project, and how an analysis and evaluation should be performed out of the view from TÜV SÜD in the TDD process. I'm now happy to get your questions.
Yeah, thank you very much for the interesting presentation, Henry. First of all, I would like to send you our feedback link now. So if you have time, we would be very happy to receive your feedback to today's webinar. And now we would be ready for your questions, and so that you have some time to write your questions down. In the meantime, we would like to ask you, Henry, some frequently asked questions. So what should a due diligence cover?
Well, as I've already shown in the presentation before, due diligence should look into the target topics, meaning your planning, your contracts, your schedule should look into the links to other contracts, to other problems. Technical due diligence never stands alone. And you should cover all the questions which are usually raised from a bank, means how's my IRR? Is this good or bad? How can we ensure the operation over our expected period? I guess this is more or less the main topics which should be covered.
Okay, thank you. And what would you recommend in a due diligence when buying an existing wind farm?
Yeah, well, this is a very special case because when you buy an existing wind farm, I mean, something which is not turnkey, operating here, usually a lot of the original contracts cannot be changed. But what you can influence and do is inspect your turbines. I haven't spoken about this in my presentation, but this is something which is part, a very special case and part of due diligence, because to get status on the condition on your turbine as they built is then also part of a due diligence.
Okay, perfect. And maybe one last question so far. In general, the question, what is the added value of a technical due diligence, meaning of costs versus benefits?
Oh, sorry, can you repeat this? Was a little bit fast.
Yes. In general, the question, what is the added value of a technical due diligence, meaning of costs versus benefit?
The big advantage of a due diligence is it is, in compared to your project in terms of cost, quite small. Yeah, so just to give you a feeling, yeah, even if you buy one turbine, which has nowadays a price of 3 to 4 million, just the turbine, not the infrastructure around, and DD is something around 20 to 50,000 euros if it's quite expensive. So, what you can save here, you invest this money, but when we remember in the beginning of the presentation, we saw this car, we don't know what's under. And we don't want to be in the position, we don't know what's under, we want to know what our asset is. So you invest, from my point of view, a very small amount of money in order to get the information about the condition of your project. And to know what is the value of the project. In good cases, you can influence problems which causing or raising you higher costs. In the best case, DD is of course some investment, but it saves you 10 times more than you would have paid if you would have not done the DD.
Okay, thank you so much, Henry. So as I see so far, there are no questions from the audience. Therefore, I would like to indicate again Henry's contact data. So if you have any questions after the presentation, feel free to contact him with your question at any time. And I think then we should close the session for today. I say thank you to you, Henry, for you and your time. And yeah, thanks to the audience and hope to see you again. Have a good day.
Bye-bye.